Hello team, this is the first lesson about OpenAI API, ChatGPT, and other AI tools. Welcome to the course. Taking into account this is our first lesson, it would be theoretical one. In this lesson we are going to learn key terms and concepts that we need to know before we go further and proceed with practical examples. So today we'll make some basement. We are going to start from understanding of what OpenAI API is. Then I will explain what ChatGPT is. I bet you already know what OpenAI API and ChatGPT are, at least on the high level, but we need to make sure that we make strong basement for our future learning. I will explain such key concepts in OpenAI API as prompt, tokens, and models. And after that, I will make an overview of the key OpenAI API models. Again, this would help you to understand the content of the course and how the information is going to be structured. Also, this would give you understanding of different features and goals that you can achieve with products of OpenAI and their models. So, we'll review such models: GPT-4 model, GPT 3.5, DALL-E, Whisper, Embeddings, Moderation Model, GPT-3, Point-E, Jukebox, Clip, Codex. So, we have a lot of things to learn today. Let's start our lesson. Even despite ChatGPT becomes a buzzword nowadays, we need to make things clear, because we are going to learn how to use OpenAI API in this course. And GPT is just one of the models developed by OpenAI. But what GPT is, I will explain in a minute. Let me explain you what an OpenAI API is. OpenAI is an artificial intelligence research organization and company that aims to ensure that artificial general intelligence benefits all of humanity. OpenAI conducts research and development in various areas of AI, including natural language processing, computer vision, reinforcement learning, and robotics. The OpenAI API is a programming interface provided by OpenAI that allows developers to access and utilize the capabilities of OpenAI's language models and other AI services. It enables developers to integrate OpenAI's advanced AI technologies into their own applications, products, or services. By utilizing the OpenAI API, developers can send requests to the API endpoint with specific instructions and receive responses containing generated text or other relevant information. The API allows customization through parameters like input prompts, output formats, and model configurations, enabling developers to fine-tune the behavior and output of the models to suit their specific requirements. And now we can answer the question, what ChatGPT is. I believe that if you watch this course, then you already have understanding about this tool. Probably you even used it already. Chatbot GPT stands for Generative Pre-trained Transformer. Is an advanced language model developed by OpenAI. It is designed to generate human-like text responses based on the input it receives. GPT models, including ChatGPT, are trained on a massive amount of text data from the internet to learn patterns, language structure, and context. They utilize deep learning techniques, especially transformer architectures, to understand and generate coherent and contextually relevant responses. It can assist with various tasks, including data analysis and generation of new data based on input provided. The model is trained to generate responses that are contextually relevant, but it's important to note that it doesn't possess real-time understanding or awareness. The quality of the responses can vary, and the model may sometimes produce incorrect or nonsensical answers. So, to sum it up, GPT is just a model developed by OpenAI, and we are going to learn how to use ChatGPT and other models via OpenAI API. Is it clear? So, when I would refer to OpenAI API in this and following lessons, that also means that I mean work with GPT and other models too. To understand OpenAI API better, let's understand the key terms and concepts that are used in the OpenAI API. We are going to learn and understand the following concepts: prompt, tokens, models. Let's learn these one by one. So what is a prompt? In the context of ChatGPT, a prompt refers to the initial text or message provided as input to the model to start a conversation or request a specific response. The prompt sets the context and provides guidance to the model about the desired topic or task. When interacting with ChatGPT, you can begin with a prompt that provides some context or asks a question to guide the model's response. For example, if you want to ask about the weather, your prompt could be something like, "What is the weather like today?" The quality and relevance of the model's response are influenced by the prompt you provide. A well-crafted prompt that clearly expresses your intention can help the model generate more accurate and meaningful responses. However, it's important to note that the model's responses are ultimately based on patterns it has learned from training data and may not always be perfect or entirely contextually accurate. Experimenting with different prompts and refining them can be a useful technique to get desired responses from ChatGPT. It allows you to guide the conversation and obtain more relevant and informative outputs. Another important concept to understand while working with OpenAI API is the concept of tokens. It is important to understand because different models have different limit on tokens they process. Tokens refer to the individual units into which the text is divided for processing by the model. Tokens are primarily used for representing and processing text data in natural language processing models like GPT, DALL-E, and other text-based models. These tokens can represent words, subwords, or even characters depending on the specific tokenization scheme used. The text is split into tokens to enable the model to process and understand it. Each token carries meaning and contributes to the overall comprehension of the input. For example, in the sentence "I love cats," the tokens could be "I love cats," 3 tokens. It's important to note that tokens can have varying lengths. Some tokens may represent a single character, while others may represent entire words or even longer subword units. For instance, the word running can be tokenized as run-ning, or using subword unit such as run-ing, like you can see on the slide. The number of tokens in a given text affects the computational requirements and performance of the model. It is also essential to consider token limits and constraints when interacting with ChatGPT to ensure that the input and output remains within the allowed token count for the model you are using. And this is an important thing. Both the input and output tokens count towards the token limit. When you send a message or prompt to the ChatGPT model, the tokens in the message are counted towards the token limit. And tokens in the generated response also count towards the limit. For example, if your conversation has already accumulated 3,000 tokens and you receive a response from the model that consists of 100 tokens, then the total token count would be 3,100 tokens. It's important to consider the token usage of both input and output to ensure that your conversation stays within the token limit and you receive complete responses. Soon we'll start learning the details of OpenAI API. and when we'll start learning them, I'm going to show you how to limit tokens in response. Now, let me explain what models are. Models are mathematical representations or systems that can learn from data and make predictions or decisions. They are designed to mimic the way humans learn and solve problems. Imagine you want to teach a computer how to identify different types of fruits. You would start by showing it various examples of fruits and telling it what each one is. The computer then tries to identify patterns and features in the examples to learn what distinguishes one fruit from another. It might learn that apples are usually round and red or green, while bananas are long and yellow. Once the computer has learned from these examples, it can use that knowledge to identify new fruits it has never seen before. You can give it an image of an unknown fruit, and the model will make a prediction based on the patterns it has learned. It might say, I think this is an apple because it is round and red. Models can be applied to various tasks such as image recognition, language translation, speech recognition, and more. They are built using mathematical algorithms and trained on large datasets to improve their accuracy and performance. The goal is to create models that can generalize from the examples they have seen and make accurate predictions or decisions on new, unseen data. So, OpenAI presents different models. This course that you are watching will be constantly updated, and most likely that by the moment you watch this lesson, the new model is developed and released. This is because the development process is dynamic and industry is evolving with fast pace. I will record new video lessons about new models and updates, but please, always verify the latest information on official documentation. For example, there is even a separate page dedicated to review of the models. In attachments to the video, you can find the link to the documentation. But anyway, let me make an overview of the models that are available based on today. This will help you to understand the context, naming patterns. So there are following models: GPT-4, GPT-3.5, DALL-E, Whisper, Embeddings, Moderation, GPT-3, Point-E, Jukebox, Clip, Codex. Let me make a brief overview of each of these models. Let me start with GPT-4. The GPT-4 model is a powerful, multimodal model designed to handle a variety of inputs, including text and images. It exhibits remarkable accuracy in solving complex problems, surpassing the capabilities of previous models. With its extensive general knowledge and advanced reasoning abilities, GPT-4 is adept at both chat-based interactions and traditional completion tasks. It is optimized for chat applications and can be utilized effectively through the Chat Completions API. On the screen you can see the page of the GPT-4. You can find link in attachments and watch the same examples, but just take a look how cool it is. You ask GPT-4 what you can cook with such ingredients, and it provides you with an options what you can cook. As you already know, each model used training data. There are always different versions of the model that are different in the algorithms, training data set used for training the model, and limits. On the screen, you can see example of the GPT-4 models based on today. But as I said, this field is evolved dynamically and most likely new versions will be released soon. So just check the documentation. You will find the link to the GPT-4 in attachments to the video. So on the screen you can see max tokens per request limit and the freshness of training data. Let me review the key points about GPT 3.5 with you now. GPT 3.5 is optimized for chat-based interactions, making it well suited for applications like conversational agents, chatbots, and virtual assistants. It can provide detailed responses, answer questions, offer suggestions, and engage in natural and coherent conversations. With its large-scale pre-training on diverse text data, GPT 3.5 possesses a broad understanding of various topics and domains. It leverages this knowledge to generate high-quality, contextually appropriate responses. You can see that there are different models of GPT 3.5 version, but OpenAI in their documentation recommend using GPT 3.5 Turbo over other GPT 3.5 models. Few words about DALL-E model. DALL-E is an advanced AI system that utilizes natural language descriptions to generate realistic images and artwork. With DALL-E, you can provide a textual prompt and witness the creation of new images in the specific sizes, make edits to the existing images, or explore variations based on user-provided images. DALL-E works by training on a large dataset containing pairs of images and their corresponding textual descriptions. It learns to understand the relationships between text and images and can generate new image based on textual prompts that it hasn't seen during the training. Anyway, this will not be a lesson about DALL-E model itself. I'm just making an overview of models in this lesson, and in the separate lessons in the course we are going to learn how to interact with the model. The next model is Whisper. Whisper is a model designed for speech recognition tasks. It has been trained on a vast and diverse audio dataset, enabling it to excel in multilingual speech recognition, speech translation, and language identification. Model was trained on 98 languages. The APIs that use Whisper model can transcribe audio into whatever language the audio is in, translate and transcribe the audio into English. Potential use case and example of Whisper model. Suppose you have a video clip in a foreign language and you want to provide subtitles or translate the spoken words into a different language. You can employ the Whisper model for speech translation. It takes the audio input, recognizes the spoken language, and then translates it into the desired target language. This allows you to provide multilingual subtitles or enable language translation capabilities in various applications. Let me explain now what embeddings are. Embeddings are numerical representation of text that can be used to measure the similarity between two pieces of text. Let's take an example to understand embeddings better. Imagine we have a set of words such as dog, cat, and mouse. We can represent each word as a vector in a multidimensional space, where each dimension represents a certain aspect or feature of the word. For instance, one dimension could represent the animal's size, another could represent its color, and so on. The interesting thing about embeddings is that similar words or words with similar meanings are represented by vectors that are closer to each other in the high-dimensional space. For example, the vectors representing dog and cat would be closer together than vector representing dog and mouse, because dogs and cats are more similar to each other in terms of their characteristics, compared to dogs and mice. Embeddings enable machines to understand and work with text more effectively because they provide a numerical representation of words that captures their semantic relationships. This makes it easier for machine learning models to perform tasks like language translation, sentiment analysis, or even word similarity comparisons. Let's talk about moderation models. The moderation models serve the purpose of evaluating content to ensure its compliance with OpenAI's usage policies. These models are equipped with classification abilities to identify various categories of content, including hate speech, threatening language, self-harm, sexual content, content involving minors, violence, and graphic violence. For more detailed information, you can refer to our moderation guide. When using the moderation models, you can input text of any length, and the models automatically handle breaking it down to fit within their specific context window. This allows the models to effectively analyze and assess the content provided, regardless of its size. For example, imagine a social media platform where users can post comments. The moderation system automatically scans these comments and flags any that contain hate speech, threats, or explicit content. The flagged comments are then reviewed by human moderators who decide whether to remove them or take appropriate action. Another example is an online forum where users can discuss various topics. The moderation team oversees the forum and ensures that discussions remain civil and respectful. They remove any posts that contain personal attacks, harassment, or violate the forum's guidelines. In both cases, moderation helps prevent harmful or inappropriate content from spreading, protects users from harassment or abuse, and fosters a positive and inclusive community. Let's now talk about GPT-3. Most likely you are wondering, what is the sense of talking about GPT-3 if there are GPT 3.5 and GPT-4? The original GPT-3 base models, namely DaVinci, Courier, Ada, and Babbage, were replaced by the more advanced GPT 3.5 generation models. While the GPT 3.5 models offer increased power and capabilities, it's important to note that only the original GPT-3 base models are currently available for fine-tuning. This means that developers have the option to further refine and customize the performance of these base models to suit specific tasks and requirements. On the screen you can see name of different models, limits, and training data used. What fine-tuning is and how to fine-tune models we are going to learn in separate lesson. Point E. Point E is a powerful and versatile language model that excels in natural language understanding and generation. It can comprehend complex text input and generate coherent and contextually relevant responses. How it is different from GPT 3.5 model, for example. GPT 3.5 is a general-purpose language model suitable for various language tasks, including chat-based interactions, while Point E is a more focused model optimized for accurate information extraction and question answering. It is interesting to know and explore Point E because OpenAI published its source code. The next interesting model is a jukebox. Jukebox is an impressive model that has been trained on a vast music dataset. It can compose original music in different genres and styles and even mimic the musical characteristics of special artists. Jukebox opens up new possibilities for generating music with creative and unique compositions. Source code is also provided at the GitHub. CLIP. CLIP stands for Contrastive Language Image Pre-training, is a groundbreaking model that combines language and vision. It has been trained to understand both images and their accompanying textual descriptions, enabling it to perform tasks such as image classification, generation of textual descriptions for images, and even finding visually similar images based on text prompts. CLIP's ability to bridge the gap between language and vision opens up existing possibilities in the field of multimodal AI. Codex. Codex models developed by OpenAI are a set of models specifically designed to understand and generate code. These models are trained on a vast amount of code from various programming languages and can assist developers in writing code by translating natural language prompts into code snippets. Codex models developed by OpenAI are a set of models specifically designed to understand and generate code. These models are trained on a vast amount of code from various programming languages and can assist developers in writing code by translating natural language prompts into code snippets. Codex models have the ability to provide intelligent code completions, generate code from user instructions, and assist with code-related tasks. They leverage the power of deep learning and natural language processing techniques to understand the context and intent behind code-related queries and produce relevant code outputs. However, it's important to note that Codex models have been deprecated by OpenAI, which means they are no longer actively supported or recommended for use. OpenAI has transitioned to newer models like GPT 3.5, which offer enhanced capabilities in natural language understanding and code generation. By the way, during this course we are going to write the applications for ChatGPT with the ChatGPT, and I am going to show you how code generation works, and we will evaluate together whether we can rely on it and whether it can be useful. So basically, that's all what I wanted to share with you in this lesson. We still have a lot of other things to learn, but the main thing on this stage is to build a good basement for our future learning. So, we are on the right way. Let's recap what we have learned in this lesson. Today we learned what OpenAI API is. Also, now you know that ChatGPT is a model, and we plan to interact with it and other models via OpenAI API. We learned the key terms and concepts that are used in OpenAI API. We learned what prompt is, tokens, and models. And during the lesson, we reviewed different models that can help us with leveraging different features of OpenAI API. Namely, we learned the following models: GPT-4 model, GPT 3.5 model, DALL-E, Whisper, embeddings, moderation, GPT-3 model, Point-E, Jukebox, Clip, Codex. That's all for today. Thanks a lot for your attention. Have a great day and see you in the next lesson.